One system controls the temperature. Another supplies oxygen. On Earth, the forests and oceans absorb the carbon dioxide we exhale. In space, the crew uses special canisters to clean the air. For a short time, this artificial system supplies to the astronauts what the Earth has always provided for us. Its natural systems slowly recycle the air, the water, and even the rock. In one cycle, heat from the sun evaporates water from the ocean to form clouds. Winds drive the clouds over land. Rain from the clouds falls back to the earth and then runs down to the sea, where the cycle begins once more. Heat stored in the clouds can drive them upwards into towering thunderheads. Inside them, powerful electric charges are building. You can see lightning on Earth from space. Astronaut Charlie Bolden.
Probably my favorite spectacular view is nighttime, watching lightning all over the Earth as it goes from cloud top to cloud top over hundreds of miles, almost as if somebody's conducting an orchestra, you know, and the lights flashing in response to the music and everything. You kind of float up in the window and look for long periods of time in amazement at what's going on down there.
In places where there is a lot of rainfall, an abundance of life springs forth. The plants produce oxygen, which we and the other animals breathe. Life on Earth is easy to see from space. Costa Rica and Panama are green with it. But other places in the world get almost no rain. In the Namib Desert, only wind has shaped the surface, sweeping the parched sand into dunes nearly 1,000 feet high. In some of the driest deserts, people have drilled for water trapped in the rocks deep below the sand. Each one of these tiny circles is an irrigated field, half a mile in diameter. But this is a short-term gain. It will take only 50 years to use up all the water, but more than 10,000 years to replace it. In some regions, like the Sahara, the amount of rainfall can change drastically within a single generation. When we started looking at Lake Chad from space, we saw that it was shrinking. Soon, a wave of droughts brought starvation to the people living here. We don't know why these local changes occur, but we do know that the Earth's climate as a whole has changed over much longer periods. During the last million years, great sheets of ice advanced and retreated several times, burying northern Europe and much of North America. This is the Hubbard Glacier in Alaska. Trapped deep inside these frozen walls is a record of climate change, going back thousands of years. By analyzing samples of the ancient ice, we may learn to predict our future climate. "10,000 years from now, perhaps the sites of Montreal, Detroit, and Copenhagen will again lie buried beneath a mile of ice."
It's moving. Looks good.
To observe large-scale changes on the Earth, we use satellites. The TDRS satellite will act as a relay, linking scientists with dozens of spacecraft watching different parts of the globe. Some study ocean currents. Others monitor the health of crops. They also warn us when storms develop. Of all the storms, the most dangerous and unpredictable are hurricanes. Without help from satellites, we could not prepare ourselves for the onslaught. Hurricane Hugo, after ravaging Puerto Rico, tore into South Carolina. What was once a national forest is now a heap of kindling. Where once there was a house, only the front steps remain. Overnight, nature's fury has devastated entire communities. But then, as quickly as it struck, the storm vanishes and the eastern seaboard is calm once more. There are, however, other catastrophic events affecting our planet. They're far more violent than any storm. The Earth is continually pelted by a hail of objects from space. Most are tiny and burn up in the atmosphere. But every now and then, a big one gets through. Some 30,000 years ago, a piece of an asteroid, weighing perhaps 300,000 tons, slammed into Arizona. It blasted out a crater almost 600 feet deep. As collisions go, it was a small one.